Alright. So, since I got a lot going on today, I'm going to just try and do one Leetcode problem and then call the end of the stream. Yeah, I've been going a lot to events lately, but I think it should be good regardless. A good thing that I'm doing. Because if you asked me a year ago if I would be going to events at all, yeah, I wouldn't tell you that I would. And things have changed. People change. I change. And maybe I become good at my craft when I do more Leetcode problems. So let's go to Leetcode. Let me try and shift things around a little bit. Okay. I'll just bring down the camera. Alright, now here's the thing. We could start doing a 1D dynamic programming problem. I might or I might not, depending if I want to finish tries or not. Should I finish tries? I think it would make sense to finish tries now. So, alright, let's finish up on tries. Okay. This is going to be interesting. This is going to be a bit tough, I think. We'll see how it goes. Okay, word search. I'm going to be probably looking at the solutions. So, give a 2D grid of characters, board, and a list of strings words. Hold on, give me a sec. Sorry. My mom had a... So weird. Mom had to like get her maps done correctly before she leaves the house. Because she doesn't trust herself that the maps are correct. And because she kind of has a language barrier. Which is a bit unfortunate. And she's too scared to actually just learn about how to use the app herself. Man, why do my parents have to get old? It's kind of sad. Regardless. Given a 2D grid of characters board and a list of strings word. Return all words that are present in the grid. For a word to be present, it must be possible to form the word with a path in the board with horizontally or vertically neighboring cells. The same cells may not be used more than once in a word. So if that's your board and these are your words, you want to only return cat, back, and back, and then words, board and words, XOXO, words XOXO. Yeah, all right, you can't go diagonally. Okay. I mean, this makes sense. I can see how you could use a try here. Interesting. Hello, Nahi. Bro, you're here already. Pretty good. And hello, Arjun. So, Nahi. Yeah. Yeah, but like, yeah. Yeah, I mean, yeah, I think mum, yeah, isn't able to trust Google Maps probably from all that. Unfortunate. The thing is though, she sometimes can't even trust the door's locked. So it's literal trust issues. More like I think it's more like ADHD, to be honest, but I'm not gonna diagnose her. I'm not gonna say anything. All right. Say we build out a try. Say we do a DFS at each point in the try. Sorry, in the graph, in the grid. If in each of the grid we do a DFS, while looking through the try, I think that would work. Arjun says how to lock in. Speak the words out loud and you'll lock in. Or try to speak the words out loud. For me, at least, that's how it works. So if I were to build this out now, I'm going to create a class of try node. We're going to have define the init function where we're going to have self, where we're going to have self dot like child is equal to the possible letters in the alphabet, which is 26. So we're going to originally make everything none times 26. Okay, 26. And then we're going to say self dot value is going to equal to some value. We're maybe going to say value from here, which is equal to none originally. And let's see, maybe nothing else for now. All right, we'll figure out if there's any. Oh yeah, if it's end of word. So it's going to be false originally, and we can make this true later. Now we got to build the try. And so we're going to build the try. And then we're also going to, after that, search through the try. No, search through the graph. Now searching through the graph is for row column in technically I can do like a enumerate, but I'll just do row in range of, okay, so rows is equal to, so board, the board can have, okay, yeah, between, it has to have stuff on the board. So the board has to exist. So the rows is equal to len of board, and cols is equal to len of board 0. Yeah. Yeah. And this is rows for C in range of cols. So row and column. For the DFS of the row and column, now during this whole process, we need to keep track of a result set containing the words, a result list, I should say. And at the end of this, we want to return the result. And during all this, we've got to actually do the DFS. So we're going to have a DFS defined. Probably we'll define the DFS just here. All right. DFS. DFS. Def DFS. Sed row call. And build the try. So let's build the try. We're going to initialize a root node is equal to try node, and so we're going to have the words for word in words. If let's see, for word in words, for character in word, root, so we're going to start from current is going to equal to the root current dot child of sed index C minus sed index starting from A. This gives you the position of the child node is equal to, either we create a new try node, so new node is equal to try node if ord C minus, so technically I could call this index, I'm just going to call this index. Index is equal to ord C minus ord of A ci index if car child index is equal to none, then the new try node is this. Otherwise, Let's see, I can do it like this, I think. Temp. So this means the temporary variable, I'm going to call it temp here. If it's none, then you create something, otherwise it's not. And you know it's there, so it's going to be temp. And so this is going to be temp. Current is going to be temp, right? Current is going to be temp. So this is just reinitializing that, but current is going to equal to temp. So technically it's going to be the new node, right? It's going to be the new node if that node doesn't exist. And if that node doesn't exist, that's what you create it as. Why not then, don't even use a temp variable, just go straight up try node. Don't, I guess, make it overly complex. You delete this, get rid of that, go to the other end of that bracket, delete that, okay. If this is none, then you create. And then you would just say, instead of temp, you do current child index. It's a little bit more writing, but I think that's fine. And so once you reach the end of the word, this current value is going to equal to, so current val, actually try node val is equal to, well, it's actually just going to be C here. Current end is equal to true. All right, there we go. Okay, so that builds out that. However, current is equal to the root should probably go after. So we start from the root each time when we build out this try node. All right, root try node. Okay, that seems fine. Then we do a DFS. So in this DFS, you got a row is you have a row and a column. Now for the board, you're given a row col. Maybe I'll just write these at C. Okay, board row col. This gives you a value. All right, or in this case, it's a letter. I'll just call it a value. This value, now you can check all four directions. So deers, maybe we'll call it directions. All right, we'll call it directions, and we're gonna use a tuple here of 0, 1, 0, negative 1, 1, 0, and negative 1, 0. Okay. Those are the four directions for deer, for DRDC in directions. If range, if fuck it. We'll just do it like this, so make it simple. Row plus dr in range of rows. Now rows means that this has to be kind of on top. Let's see. G. Ooh. G8. Ooh, wait, how do I go to a row that's 8? Fuck, I forgot. Hold on, give me a sec, Vim. Go to line in Vim. Oh, it's a number and then G. Okay, 8G. There we go. Paste. All right, so rows and columns. We might make these rows, cols, which means we make these rows cols. And range of rows, if range of rows, and C plus DC in range cols. Hello Shah Jalani, hello. It's been a while actually. So if this is not in this, or this is not in that, then let's see, we would continue and not do any of the things there. Actually, let's make this a little larger. Okay, let's make this a little larger. All right, cool. Let's see, so how do I think? So with all of these directions, DFS on the next row plus dr, column plus DC. All right. But we got to keep track of the word that we're currently building, right? However, does that mean that you don't want to go in maybe all 4 of these directions? And instead you only go down the direction which gives you the value. Now again, of these words, which one gives you this value. Let me think this through a bit, now that I've built up a lot of the boilerplate. So you're given the board, you're given the words. Not all of these words are in the board. However, you got to search through the board to find whether each of these words exist. Now, to find if each of these words exists, you need to first look at the first word on words, bat. Then you start from B, you go to A, but then you can't go any further. So then you return false. Then you have cat. You try any of the C's that exist within the board. CAT, if one returns the full string, then you're good. Backend, stack. What does this mean though? How does tries come into play at all? If you use a try, you can perhaps keep track of all possible combinations of the board, but that's not really space efficient, I would say. It would probably be better to build the try of words that you're trying to build, you're trying to get. Right? And then maybe when you search through the board, if none of these, if A isn't there, then you would go to B. If B would have a starting point, you would then go to the neighbors around the board, A, and C, and then you would again validate that you can go through the A's but not the C from that try, and then you would say, all right, let's go expand out the A's. Well, you can't go to B again, but you can go the S. And you can kind of build out a visited set or visited node, right? You have to keep a visited set. Because if this, if row column in visited, then you would return. Am I convinced? Oh, Shahjalani, you've been approached by a US firm trading. Oh, nice. Hell yeah. See how that goes. Oh, Nahi, I see. I see what you mean, huh? A slight slight OCD. That's fair. But I've had similar issues in the past, but look, we need to flow like water. We need to be flexible and flow like water. Now, where's my CPU 100%? Disk images. All right, here's what I'm going to just quickly do something. Because I think my computer's slowing down. Save the bookmarks! If I can. If it'll respond. Yeah, stream should be glitching actually. Stream should be glitching. Because my CPU is spiking up. Okay. Wait. Okay. Weirdly, it's fine now, but it was at 100% for a while. Just before. Not sure why exactly. Macs just do random things, I guess. Does that mean that we're fine to continue? I think we're fine to continue as is. Okay. All right, so you go down all the possible. You would have to use a DFS here. You can start from. You can just do it for each of the rows and columns. I think that makes sense. And okay, yeah, that makes sense. The thing is, if row column in visited, you would return. If it's not visited yet, then you do visited add the row and the column. And if given this is the value that you care about, if this is the value that you care about, is this value in this position odd of A. So this is the index of a given. So in this DFS, we might need to also start from a given state, in which case the state is going to be always the same. If it's always the same, it's got to be the root. We're going to just call it node. And this is the node child of this position. If this is not none, so if it is none, though, then you wouldn't do anything. You would just return, or actually you would return false, because you didn't find a true full word. If it's already visited, then you would return, ooh, maybe. Okay, maybe you return falses. Maybe you don't do anything. Give me a second to think about that, actually. All right, we'll come back to that. However, John Branzuela What are you using to take down notes? This is on the right side, Obsidian. It's called Obsidian. Okay. If this is none, you wouldn't do anything further. You would go back. And then once you're back, you would visited remove the row column. Directions, DRDC, and here you would also have the node that you care about. Which we're going to say is equal to next node. All right, if next node is not none, then you know the next node is what goes here. Okay. And this means the DFS here, we're going to use the root. Okay. However, if the next node does exist, then you would do the rest of that. But if it doesn't exist, hold on. When do you ever stop this DFS? Like, what is the win condition? The row, the column, not visited. If the node that you're currently at has an end in it. Then res.append the word buildup. Now the word buildup is something we haven't done. However, we can do this, I think. It's almost like backtracking. Nomsies, do you ever plan on getting into something like YC? That's a good question. I mean, I did a little bit of startups in the past myself, but it was like local uni type. It wasn't really in, international. It wasn't in America, but like it wasn't YC. But, I think in the future, at some point when I'm more skilled, I will. But I want to go into big tech first. That's my plan. and then, you know, have the skills, have the, I guess, the talking skills, or even meeting new people. It'll all come around at some point to maybe doing something in a startup. Definitely. Okay, so you can build up a list. If that's what you're going to do, maybe we can just do a, you know, canvas. We're calling it a canvas. What do I call this? Like constructor, maybe. Yeah, constructor is how I've called it in the past. Constructor. We're going to make that into an empty something. And then we're going to say add this, and then constructor dot append. Ooh. Well, since it's a string, I don't think you can actually do that. But I think you can string append this, which means it'll be board RC. Okay. I'm hoping you can do this, otherwise I know the other way to do this. Actually, never mind. I don't think that's possible. I'm just going to say construct is equal to construct plus board. All right, let's also call this construct. And we're going to res append construct dot copy. I forget if there's a, I think there is an O in there. Construct.copy, and this should be non-local. Okay, non-local construct. And then we string slice this construct at the end. Equals construct string slice it at -1. All right. That should do the construct part. If we ever revisit, if we ever reach the end, then we know that's a word. If we ever go to the next node, if we ever can go to another node, then we would continue. So even if you reach the end, it doesn't necessarily mean you've reached the end. So that's fine. But then if you do reach the end, then you would not continue anymore. And then you check out all the other different directions. If they're not within the ranges of the board, then you wouldn't do anything for that and you would continue. And then you would do the DFS of all the other possible combinations, and then you would, I guess, clear the visited. You would kind of do a backtracking as well. Okay. And then search through the graph. I think that should be fine. I don't know how this is going to work. This might fail. Output empty. String object has no copy. Okay, that might be because it's just a string and you don't really need copy. Okay. Why is this so cooked? Let me think. It's giving the right number of, but it's not giving the correct. Yeah, it's not giving the correct something. So we will print what construct is and just have a look further. Why does it seem to me that perhaps we never go back down? So we got AB, right? A, B, C, C is not a possibility. So if A is not a possibility, then you shouldn't even have A in it anymore. Yeah, so maybe what I need is to move this section. Oops. Move this section down. Okay. My output is back, backend, cat. Yep, so this is getting better. So what, you can make back multiple times? Is that what's happening here? B A C K C A T C. No. Alright, what's happening here? So backend, back, cat. Okay. Like, I know the simple way to fix this is to just not include it if it already exists in the result and make result a set. You can do this, but can I do this without making it a set? And just make it on if its node end is equal to true. Node end is equal to true. Check all the other options around you. Right, you're checking all the other options around you, right? If the next node is not possible, I gotta try it. So I don't know if what I'm about to do is right or wrong. OA. And this is because you can have OA multiple times, I'm guessing? Yes. Yes, you can. All right, that means we're on the right track. We are. I'm just going to say then, if that's the case all the time. Oh, wait. This should work the way that I thought about it before. Back, and back. Yep, okay. Then we're going to say, instead of append, we're just going to go res.add. Make, let's see, res a set. G. And we make anything else. A list back into a list. We make res back into a list. Whoa, expected output A. My output was nothing. Yo. All right, well, let's run through this. For the row, the column, all right, you're gonna have A in the try node, all right. You're gonna go, is it invisited? No. Damn. We did a hard problem without even looking at the solutions, guys. We did this hard problem without looking at the solutions. That took 52 minutes. About. But we solved it. And it was a little bit iffy because technically I still don't, I could make this a little better, I feel. Or make my understanding a little clearer. Because I call it the next node. When, why don't I instead just move this whole section to as the node? So my thinking is, you know, this is good and all, but could I do something like this? Call this next node. Move these two up. Move this down. Remove construct. Let's keep that there for now. Make that next node. There's some part to this that I'm missing. The thing is though, I will look at the solutions. It might make it clearer for me. However, I gotta go to the gym in just a minute, in 10 minutes. So I'm gonna do that, but that's good that I solved this problem. I need to understand the solutions of this problem still, right? By watching the actual video solution. So, okay, you can use backtracking. You can use backtracking try and hash set. Backtracking with try only. Okay, all of these different methods are pretty big, and I would definitely say I did use some backtracking in this problem. I will say though, if that's the case, let's create a new search for word 2. All right, and paste this and then say used backtrack. Okay, so used backtracking, DFS, and graphs. The DFS tries and graphs. Technically, we also use hash sets or hash set. I solved this problem in about 40 minutes. Yeah, 45 minutes. But it did take some time to wrap my head around my own solution. I am going to revisit this after the gym, but I don't need to say that. I will need to watch this video solution. I will need to understand exactly how my DFS works here. My main concern is with the next node, because I want to make it so that the next node is this node or is this current node. And I think that would be clearer than what I've done here as my current implementation. If that's all I need to think about, then first though, let me add this to Alacrity. I will go into Leetcode, nvim, create a new what's wedge search? So 212 word search 2.py. All right, paste. Right, quit all. Git add. Git commit. Feat solved hard problem in 45 minutes myself. Git push. Okay, so we committed that. However, we're going to come back to this, make it understood to its entirety. That'll say, well, I'll be back 12:30. If I'll be back 12:30, I'll have lunch. Damn, I'm not going to have enough time. All right, but the concern here, the concern right now is to make next node more conventional. It is currently not logically sound to me. Okay, so I'm coming back to this. So the next steps here, watch the video solution. Try to change next node to a more logical formulation. And then call it a day. I think there's really nothing else beyond those 2 points for that question here. What else? Maybe I'll add it here just because We are good. Now, if it doesn't work, I'm actually going to be a bit surprised. Oh, output limit exceeded. Now that makes sense though. Ooh, this one's also got time limit exceeded. It doesn't pass one of the test cases. Okay, Leetcode. Alright, we're gonna have to come back to this then, hey? Alright, no worries. I'm gonna call it a win because we did pretty well to understand a lot of it. The video solution I gotta fully understand later, but I gotta go to the gym now. So we're gonna call it a day for now. I probably will come back to this tomorrow to make it better. Alright guys, peace.